images for us to see. Taking in all the views, give fuel for our curiosity. Up and down, round and round, even shots from the ground. Pics from this side and that side, and the awesome overhead. Ooh yeah, Mauricio, you the man. Flying through the RGV, click, click, click. Flying out from Brownsville, click, click, click. Flying over South Bay, click, click, click. Flying over Starbase, click, click, click. Flying over Massey, click, click, click. Flying over Massey's, click, click, clickety, click. Massey, Sanchez, Brown site, White site, launch site, build site, and the ASU. Watch out for squirrels, did it go down? Go to rabbit hole. Hosts of knowledge and insight from industries all around. Matt Industar, Stephanie B, Zach B, Jay Ryan, Evan Dude, Jake Alex, and Chrome Kiwi. All talk and chat for you and me. All talk and chat for you and me. You the man, flying through the RGV, click, click, click. Flying out from Brownsville, click, click, click. Flying over South Bay, click, click, click. Flying over Starbase, click, click, click. Flying over Massey, click, click, click. Flying over Massey, click, click, clickety, click. Mauricio, the real man. I really don't wanna land.
Plain picture. Okay, we're live. Thank you. G'day everybody. Welcome to Flight 13, Take 2. So, let's hope we get a flight in today. So we're also, as you can see, we're up flying as well. Mauricio's up there flying around. And hopefully we get some more incredible pictures of the launch like we've been doing in the past. So I think SpaceX is, 6 minutes behind schedule this morning. So still on track. Pretty well on track, so that's a good thing. So we'll just have to keep an eye on things. There's Fred. G'day, Fred. Fred in the right-hand seat.
Yeah, we should be about 1 minute from prop load starting. 37:30 is when ship locks should start loading.
Cool. That'd be nice if you keep that updating for us there, BJ. That'd be lovely. Thank you. So the intro video was actually us flying. Okay, cool. That's what tricked me. Alrighty, I was waiting for this 5, 4, 3, 2, 1 to an intro video. Alrighty, cool. So we're going to try and do a full flyover today. So while we're waiting for the launch, I think we'll be getting some Massey's photos, perhaps. Let me see over here. Oh, we've already got a heap of photos. Wow, cool. Okay, so we've got pictures of the new water facility there at the Brownlot. I was getting some port photos there by the look of it. Can see the launch pad there up in the distance, and a few vapors going, which is a good sign pre-launch. But SpaceX isn't quite live yet. Oh, they should be. All I get is a, what do you call it, a circly line on SpaceX.
Yeah, they were going live at 6:16. I'm at 6:13 Eastern time, so 5:16 Starbase time. Still another minute or two.
That's what's going on, thanks, yep. Okay, so welcome all the YouTube members and others there in YouTube chat. Looks like a beautiful day for a flight today. Beautiful clear skies. Tiny bit hazy, but nothing we can't handle. And so for SpaceX, that's a good thing because they were wanting to get some images of the nose cone, the tiles on the nose as they go up through max Q. Because today, if I understand correctly, the max Q is going to be greater this time than it was in the previous flights. So which means, I guess that means it's accelerating a lot quicker, the version 3. So maybe the flight 12, they didn't actually go full throttle, and they've even got more load on this time, so perhaps this flight they're actually going to use a bit more of their available horsepower, or thrust I should say. We did notice on the first version 3 flight that it did clear the pad a lot quicker than, well, somewhat quicker anyway, a lot quicker than previous version 2 flights.
Yeah, it should be accelerating here pretty fast off of that the launch pad, like you were talking about. They're going to have an interesting profile this time because of what they're trying to do, and we also kind of learned, it seems like, that whole 270 roll that they did off of the launch site was for tile looking, and that kind of got clarified by the fact they didn't want to launch in clouds. So we're all about the tiles, it seems like, on these launches.
It's pretty impressive, that 270-degree roll program on launch, I must say. I thought they were just sort of starting to exercise a bit of flight control. Sort of like what they're doing the ship in it's after the re-entry, they're actually flying it around a little bit, which is pretty cool.
Yeah, really quickly.
Yes.
Brady G was asking about how do we know that we're when you're flying a plane, how do you know you're out of the keep out zones? How do pilots know that?
GPS devices. Plus, part of being a pilot is being navigate. You got to be able to pass navigation tests, but simple handheld GPS with those programs you can load up for pilots. I'm just trying to think of one off the top of my head. There's like a lot of different applications that pilots use, even on their mobile phones or a tablet. They tap into the GPS system and they have all of the current TFRs linked into the ATC's computer system live, so they have all the current TFRs. Some of the pilots will fly closer than others. Same with the border, not crossing the border. If you're going to fly, you really need to know how to navigate extremely accurately, like really, really accurately. Especially later on, if you do anything commercial or instrument rating. So if if you're going to pop out at clouds at 200 feet, you don't need to be a few meters accurate. You need to be like centimeters accurate. With modern navigation instruments, especially with GPS, these days pilots are allowed to use GPS as their primary navigation. In the past, when GPS started coming out, you weren't allowed to use GPS as your primary nav. So yeah, just a simple GPS device is all you really need with a app, one of the flight apps. A big long intro for SpaceX on their broadcast.
Yeah, I've seen tablets or just phones, doesn't really matter, or you can have some fancy dash nav systems as well. And it will show on there where you are in relationship to where all the zones are, if they change or if they're just, been there for a long time. And this would be the same for what spaces you're going through because different space have different requirements for what you're flying through. So it's all the same kind of concept and a lot of technology these days to figure it out. Don't have to rely on beacons or anything else realistically.
Yeah, when we were there, we did the helicopter tour at Vix when it was. That was a lot of fun. But he just had his phone on his lap, just watching the map where he was supposed to be and not supposed to be. Just regular Google Maps.
And big old donation from our very own Indie Star for $200 saying, best views of launch is always from the air. Thanks for making it up there today and every week the weather allows it. Plus, I'm a sucker for double flyover weeks, and only Mauricio makes that happen. Thanks, Mauricio.
Wow, go Indy, good on you.
Indy, you're amazing.
And we're getting some waves.
SpaceX's intro is still running, and we have aerial photos now as well from the camera. Oh, SpaceX is live now. I'm going to put SpaceX on in the background over here to listen to. Okay, Indy, yeah, go Indy. Probably got T-minus 34 minutes. Hey, is that, T-minus 30 minutes.
And we can see now on the live cams that we do have frost on both LOX tanks, both on ship and booster.
Prop load is underway, cool. Okay, so we can have the SpaceX stream as the main window. Silver 16s if you want or can. We can have their audio too.
On Tower 2 here at Starbase.
And this is an exciting day for the Starlink team as well, as we're planning to deploy 20 of the newest generation Starlink satellites.
Talking about
These sats are intended for operational use and will only be in space for about 20 minutes before demising. But during those 20 minutes, we're going to attempt to speedrun a bunch of tests. Things like deploying solar arrays, firing thrusters. We'll get into those a little bit later into the show.
Yeah, and what Starlink engineers learned today will be essential to deploying operational V3 satellites into the Starlink constellation on future Starship flights. These larger, more powerful next-generation satellites are designed to boost orbital capacity, strengthen the overall network, and deliver a noticeably better experience for our customers.
And as we've said before, Starship is a developmental program. What we're doing today is a test. We test in flight because it's the best way to rapidly
we're not
iterate
seeing
the
the
design,
pictures on the
and it's the
YouTube
best
stream.
way
I
to
just
put
got
the vehicle through its
Mauricio
paces in the
over the shoulder
conditions
shot.
it will experience
Fly
during
around.
the operational
Looks
mission.
at Code Pro, maybe.
Exactly. So while we have real Starlink satellites on board, the most important payload today is data. But no matter the outcome of today's test flight, excitement is once again guaranteed.
SpaceX.
Now let's head a couple of floors upstairs where Dan Hewitt is just outside the Launch Control Center. How's it going, Dan?
Hey, Nate. It is going great. Hi to you and Kate. Hello, everybody else. I'm Dan Hewitt with SpaceX Communications. Happy to be here with you for another launch day. As Kate noted, our first attempt to launch this flight test last Thursday ended early in a pad abort. Let's dig into that a little bit. So 4 of Super Heavy's 33 Raptor engines aborted at startup due to issues with their aux turbo pumps. Those rapidly pressurize and feed liquid oxygen into the engine for combustion. For those of you that like to pay real close attention to the on-screen telemetry, you saw this at T0 during that first attempt. We command the engines to start up simultaneously. You get some slight differences as the engine adapts in real time, but you saw 4 not light up. So 4 out of 33, what exactly happened? We have a launch constraint built in where we can only be down 2 Raptor engines at liftoff. So the vehicle detected more than that, we're out. Automatically aborted before the final T0 safely shut down all of the engines that started up. We dug through the data, and what we saw was some off-nominal spin response in the aux turbo pumps on 6 of the engines.
Hey, wonderful day for
so the most likely root cause was determined. We were collecting some moisture inside of the pumps from previous operations, which then froze when we introduced that cryogenic propellant, and that either slowed those pumps down or stopped them completely from spinning. So for this next flight attempt, we swapped in 6 engines that were already at Starbase, and we did a test back on Wednesday that allowed us to check out the newly installed engines and spin the aux pumps on all 33 after they were chilled.
I find it interesting that they only have a 2-engine
into another launch
capability
attempt.
right now.
We pulled a bunch of those engines off, as we said. We tested one on a test stand up at McGregor, helped screen for any other issues that might be hiding, and that one was actually able to do a full booster ascent burn.
So it's saying they had some
got us in a good position for today.
A couple of the turbo
Even though we
pumps.
didn't get off the pad last week, we learned about the engines, the prop systems, how they perform in the flight, and more reliable.
What's Brian
saying? Real-world test of an abort that's designed to take place at one of the most critical, dynamic phases of flight. We safely shut down 29 running Raptor engines.
Okay, so I'm listening on YouTube. So I'm delayed with my listening, but I'm live on the
aborts. You've got software hardware engineers just dreaming up bad day scenarios. How we
I'm looking at chat. So good day, chat. Welcome everybody. It's 77 out there.
Maximize safety, preserve the mission, and the
so we're a small broadcast today, but that's fine.
This is now Flight 13's
usual Motley crew over there on YouTube, and
really good at the moment. Just behind me here is the launch
members
control
here
center.
in the
Everybody's on console, looking at the systems on board the vehicle and on the pad as we count down to liftoff. Propellant load is underway. We slipped a little bit into our window as we waited for some last couple of things to
my mic is still low.
We are targeting a liftoff at 5:51 p.m. Central Time.
Oh, you're gonna hear. Okay, you're gonna hear that in the background.
We've got blue skies. We're gonna do a little weather corner here for a second because we were originally attempting to fly yesterday.
I believe
and we didn't because of we said weather.
Cool.
I want to be clear.
Okay, there's the prop load, 32%, 38%.
Nothing to do with launch weather constraints. One of the key goals of this flight is to get very clear imagery of the tiles on Starship as we're flying it at a higher dynamic pressure. You can't do that when you have clouds completely obscuring your
probably want to see the
all of those critical phases
GoPro camera on the wing as we get closer to launch. T-minus 25 minutes. Cool.
Because we've done a ton of testing. Unique testing,
doing well, 6 times, it's looking perfect.
Studying aircraft capabilities, and it's designed because that's ultimately the cadence we want to fly at, like an airplane.
I just don't have all my screens.
We're going to utilize that new capability carefully, but we're very aware. If we want to fly Starship as often as you could fly an airplane, you're going to have to fly in weather that historically would keep rockets on the ground. So we're doing that analysis. We're doing that testing. Aside from weather, we're watching the range, both in the Gulf, right here off Starbase, and in the Indian Ocean. That's currently green. We are not tracking any vehicle or pad issues that would preclude a launch today.
I'm pretty sure. Can we have a 5x5 for our voices?
That launch infrastructure is every bit as complicated as the rocket itself. It's designed to operate in some of the most extreme conditions on Earth.
Just like a 5x5 or whatever in chat for our voices.
Into what it takes to launch the most powerful rocket on the planet in the second episode of our ongoing documentary, Starship.
Thanks.
When we're only a week out from flight, my main focus is getting into flight.
The sign, the gateway sign was there.
The thing that separates us from a lot of other companies is that we test fast and we test often, and that includes launches. We want to make sure the vehicles are ready to go. We want to make sure the ground's
images till a bit later in the coast phase.
I'm
bored. When LBN1 looks like it kicked out due to 2 combustors from the apex being pelted.
Yeah, I understand.
There was a pad side abort
and I had my
call.
headphones on.
These things were holding like 5,000-6,000 tons of propellant plus the rocket weight, and it's like, okay, well, why didn't you guys simulate that? It's like, well, because we didn't have anything that weighed that much. Like, this is the first time we put anything on it that weighed that much. So there's just so much that you have to think about and be very paranoid on.
We kicked out early. All teams triage alerts, prepare for offload.
We actually had another pad abort on the diverter.
Basically, right during engine firing, it was so much noise and vibration that it actually shook the sensors that are located out in this area enough that they aborted us out of the test. We went back, obviously, afterwards and looked at all the data and tried to come up with smarter ways to basically still protect the integrity of the diverter throughout the operation while changing our parameters so that we were making sure that we would not abort again.
11 by 7 is like a super simple 11/7?
That is like not at all complicated in operation and is just absolutely murderous in the details. These are extremely sophisticated thermal load sensing devices. If they turn into melted metal slag, then you know that you got too much heat. If you melt this, you're hotter than aluminum melts. If you melt this, you're hotter than zinc melts. If you melt this, you're hotter than copper melts. If you melt this, you're hotter than Sharpie melts. So we're sub-Sharpie. We have all of this mass flow, all of this energy that is just absolutely trying to obliterate our pad. We want to give it a thing to obliterate, to keep from obliterating the things that we care about. And the thing we give it is water. The amount of energy that water can absorb is like miraculous. And so if you can get high enough pressure water in the right places and just allow it to flash boil that water, then it solves a lot of the problems for you. Like the idea is that the steel never gets that hot. The structures never get that hot because the water absorbs all that energy, turns to steam, and everything's okay.
So for this flame deflector on pad 2, we're sitting somewhere in the neighborhood of about 650,000 gallons per minute.
20 minutes.
That's approximately in the range of about like one entire Olympic swimming pool being drained in the course of a minute.
We don't call them Sharpies in Australia, I'm actually calling them permanent markers.
You're trying to look into this thing and you see how glowing hot it is. It's just yeah, a pretty impossible environment to keep something happy in. But and you zoom in and the flame deflector's still there, so that's the reason we build those things.
Putting the rocket into human terms is something really tough. 65,000 pounds per second of propellant that is coming out of the engines. And again, just like 18 million pounds of thrust, like what does that number mean? I think of like 11 Ford F-150 trucks per second just zipping out of the bottom of the rocket. It's like imagine if you had the world's biggest machine gun, except for instead of shooting bullets, you're shooting pickup trucks, and it's just firing 11 pickup trucks per second out of the bottom of the rocket. It's like, do you think your stuff could survive that?
And it is so satisfying to watch the slow motion flame diverter shots.
Right, and just hear all the exciting stories of how we tackle these problems.
I did get a kick out of after Flight 12 when somebody created a graphic with
that looks like fun to you,
coming
come
out of the
join our
bottom of the
team.
rocket.
We are seeking scrappy problem solvers to help us build the future.
Oh man.
Oh, maybe I did.
Okay, let's go meet the rocket out on the pad, Starship version 3. It's the most powerful rocket ever developed and ever flown.
And it's also the tallest at just over 407 feet tall, fully stacked. It is massive. Standing at the base and looking up is like looking up at a 40-story building. Incredible.
Yes, it's a two-stage rocket. Both stages are designed to return to Earth and fly again, making that thing that you see on your screen the first fully reusable rocket ever.
Yeah.
The bottom half,
we saw it in
the first stage, is
and that was from the
super heavy booster.
25-second
That's the
static
silver
bars we're
part.
talking about, not
it's
this
powered by
fake,
33 of our newest
1 second static bar
iteration. You
thing.
see them there on your screen now. Raptor 3 engines.
Oh, that launch
They
thing
run
that's
on
supposed
liquid
to
methane and oxygen, and this version of Raptor provides a significant increase in thrust. With that additional thrust, as you can see here by these comparisons, the version that we're launching today, version 3 on the far right, that version of Starship gets off the pad much faster than our previous versions. The one on the far left,
that's
I believe,
Flight
is
1 on the
actually
left.
our
Look at the
Flight 1
debris
footage.
flying up.
In comparison, they really just go.
Yep. And now Super Heavy has 3 great fins, which you can think of as aerodynamic rudders. You see them on your screen now. They help steer during landing. They're 50% larger than on previous booster versions and are designed to support rapid reuse and a more stable atmospheric reentry.
I don't think that qualifies as
and at the
bits
top of
of
the
concrete.
booster,
That
we've
was
got the hot stage
of
adapter.
concrete.
It's designed to protect the booster during separation, and now it's fully integrated for reusability.
That was like
and stacked right above that is our upper stage of the rocket, or stage 2. It's what we call ship. It's powered by 6 Raptor engines, 3 optimized to sea level performance, and 3 for the vacuum of space.
Ship's design could one day enable point-to-point transfer on Earth, meaning you could travel anywhere on the planet in an hour or less. Sounds pretty great to me.
Sounds awesome.
It's designed to carry massive orbital payloads, both cargo and crew, to Earth orbit, the Moon, Mars, and beyond.
And for the first time, we are carrying real Starlink V3 satellites to space. For more on that, let's head out to California, where Tyler is standing by with the team in Hawthorne. How's it going, Tyler?
Launch crate.
We're doing great over here, Nate. Thank you both. I'm Tyler
Lionquist,
and I'm a Starlink business
analyst
at SpaceX. Now, for those of you who have been following along, the Starlink version 3 satellites have been designed to take full advantage of Starship's payload capacity. And we're going to get our first look at those satellites today. The Starlink V3 is our next-gen satellite, and it includes meaningful increases in capacity, data density, and power generation. So we'll be adding around 20 times the capacity into the constellation on each Starship mission as compared to the version 2 satellites that we launch on Falcon. And that means that we'll be able to serve more people all around the world and with increasingly better high-speed internet. Like all Starlink satellites, the V3s are built at Starlink's site in Redmond, Washington.
6 times maybe we can just turn SpaceX down a tiny bit in the audio mixing.
Now the V3 sats are designed to support 1 terabit per second of downlink and 160 gigabits per second of uplink capacity. That's approximately a 10 times improvement in downlink capacity and around a 22 times increase in uplink capacity from the version 2 Starlink satellite. Serving this capacity to and from customers are the satellite's upgraded phased array antennas. The upgraded
okay, we'll do a test there for the audio, just so our audio comes through a bit better, that's all. Thank you.
More efficiently in both densely and sparsely populated regions simultaneously. And each Starlink V3 satellite is also equipped with 6 high-capacity 400
What's that
gigabit
big
space
word?
lasers. Now, these 6 lasers will allow high-bandwidth traffic to flow uninterrupted between any 2 points in the world with redundant paths across a petabit laser mesh network. And if that wasn't enough, the V3s will carry 4 quad-band radio frequency backhaul antennas. And these will take advantage of the Ka, E, V, and W communication bands, allowing for an 8 times improvement in supported capacity compared to the V2 sats. And that's a lot of growth in capacity and capability. And as such, the new satellite design requires more power. So the solar arrays on V3 will generate approximately twice as much power as the current arrays that we fly on the V2 satellites. And they're also optimized to reduce drag in the lower orbital altitudes in which these new satellites will operate. But before we operationalize these satellites, we want to put them
Can you hear
in
me?
a flight-like environment.
Yeah.
These satellites
Oh, sorry, heterochromia.
started
2 different
last
colored
week
eyes.
ahead of that first attempt.
Yeah, I got it.
And once deployed, the Starlink team will
You didn't hear
only
me before,
have
I
about 20
assume.
minutes of flight to speed run some of these tests before the sats to
No, nothing.
Okay, good. Well, backing up since I was muted apparently. Shout out to Pin What for $25. Safe travels, Joe.
Connecting with ground stations and turning on the satellite's communication systems.
And another $20 from Peter.
From the very beginning,
Stay
Starlink
safe.
was designed to
Thanks for
scale
your SpaceX
rapidly and
coverage,
continuously.
Pitt in
From
Switzerland.
production to launch and ground infrastructure, Starlink is uniquely positioned to keep pace with rising demand around the world.
Thanks,
In
6
fact,
times.
Just last week, we rolled out the next generation Starlink pin.
Thanks,
the
man, dudes, and
V5,
thanks for
which
all your
is built
generous
for reliable,
donations.
high-speed
Awesome.
home internet.
Gotcha. Is that Tyler saying with heterochromia?
What was that, Steph?
Ah, is that Tyler who's got heterochromia? I'm wondering who you're talking about.
Yeah, Taylor does.
Ah, cool. Thanks.
The Starlink lady. Business lady.
All right, you heard from Tyler. A lot of work going on with Starlink. We've also started development on an entirely new satellite constellation, Starmind, our AI satellites. I got to sit down with Elon and Starlink's director of satellite engineering, Ian Dahl. We covered a whole bunch of stuff, really focused on what are the 3 limiting factors to making data centers in space a reality. First one we talked about was mass to orbit. That's where Starship comes
Is this
in.
new footage live, or are they replaying last launches?
Combining its full reusability and the really big
some of it's been replayed from what they did at Flight 12,
that we're
but
talking about, because
this seems to be he seems to be going towards some new stuff
those
now.
are going
Though
to function as those orbital data centers using Starship for the high volume.
not the specific, though.
A couple of really key reasons why moving data centers to space has advantages over building them here on Earth, which gets into our second limiting factor, which is power generation. It's always sunny in space. Satellites can harness that sun, that near constant solar energy, which is really going to be the only way to scale if AI continues to grow at the pace that we see, especially when you contrast it with all of the challenges that you have here on Earth. Within about 2 to 3 years, we believe space-based AI compute is going to become the lowest cost option
Star
as
Lady
those launch
says
costs
done,
continue to drop and Earth-based constraints.
And thank you to Yazada for $10. Thank you, Mauricio.
How Earth powers AI, unlocks the
Thank
future.
you, Yazada.
And then our third limiting factor that we got to go figure out is going to be
another
chips.
long term.
We got to do that fast, and that's what we're doing with TerraFab. That's going to be the most epic chip building effort ever. Not just
long-term
cool
SpaceX fan too. Sees through the channels over the years.
Location to do it. We're talking 100 million square feet. So
it's a Groundhog Day. Very good.
Factories. All of this together sounds a bit fantastical. A bit
Dang,
out
that's
there,
a big
but these
factory.
Are real steps that we're taking right now that are going to set us up to eventually become a galactic civilization. That sounds really cool. I mean, harnessing meaningful amounts of power from the sun, supporting all of those AI applications that are going to change our daily lives, and making humanity a multi-planetary species. If you want to learn more, you can watch the full conversation on our website. Hopefully a link appears on the screen. If not, go look up Starmind. So the future is looking pretty sweet, but first things first, we've got Flight 13 ahead. Let's jump down to Kate and Nate for what's ahead.
Thanks, Dan. Yeah, the future is built on progressive steps like today's test. So let's dive into the flight profile that we're going to see today.
That's right. We've got an exciting day in store. So starting with liftoff, super heavy wall.
Both chugging away, full on.
3 engines right off of Pad 2 here in Starbase. We will then power through ascent ahead of hot stage separation, where the booster will shut down all but 5 engines at the bottom. Stage 2 will then light its own Raptor engines, pushing off from Super Heavy and starting our stage separation maneuver known as hot staging. We will then have the directional booster flip using 33 engines, and after coasting for a few minutes, the booster today will target a landing burn and ocean splashdown a few miles off the coast of Starbase.
Ship is going to keep the party going with its ascent burn to a suborbital trajectory, followed by deployment of those 20 Starlink V3 satellites. We also plan to relight a single Raptor engine. Re-entry is just a few minutes later, which should provide some amazing views thanks to Starlink. And typically we see some pretty fantastic views of the ship's blistering re-entry through the Earth's atmosphere. A plasma blanket will form around the vehicle and never prevails to provide epic scenes. And lastly, we'll conclude today's test with the landing flip,
pumps
a
are
landing
working,
burn, and a splashdown in the Indian Ocean. And with that, let's kick it over to Dan for a countdown update.
Thanks, Kate. Good news. We just heard from the flight director. We are T-minus 10 minutes. We're a little bit past that now, not tracking any issues for launch today. Range continues to be green. Our range team hard at work, making sure we're clear out in the Gulf and in the Indian Ocean, where we're going to be sending
cool. Under 10 minutes,
weather
range is clear.
Gorgeous. Again, no clouds. We scrubbed our attempt yesterday, or didn't even try yesterday, because we had such poor visibility. Weren't going to be able to see those tiles on the way up. That's a key kind of experiment objective for this flight today, and so we're looking really good with weather today. In the future, we'll see what kind of adverse weather we can fly into. We are capable and allowed to launch into lightning, but we're going to utilize that new capability carefully as we eventually continue to evolve Starship to fly it at an airplane-like cadence. You can see the prop load there on your screen. We're just about closed out on the main tanks on the ship. We just started propellant load in the header tanks on Starship. Those are the two smaller ones up top.
We got a photo right now.
For the in-space
it looks
burn
the same as the SpaceX feed.
Burn at the end of its mission. We started loading our propellant at about
5
minutes today, and we're going to continue all the way down until we're inside 3 minutes to launch. We'll close out at about T-minus 2 minutes and 50 seconds on booster, and then 2 minutes and 10 seconds on the ship. So at the moment, we're looking good. That launch time, 5:51 p.m. Central, a couple of minutes into our window today. So we'll be back real soon. Toss it back down to Kate and Nate.
Thanks, Dan. Recently, NASA announced the astronauts for the upcoming Artemis 3 mission. The Artemis 3 mission is a crewed demonstration mission in Frank Rubio, as seen there on your screen. They will crew the mission and it's slated for 2027.
It's a great crew, and it's also the penultimate mission, the final test before Artemis 4 attempts to put astronaut boots back on the moon for the first time since 1972. We'll be launching a Starship with a docking port on the nose so we can practice rendezvous and docking with the crew. And one key test objective comes after docking, where we will be able to test out maneuverability of the vehicles together while in space. This has the new importance as the revamped plan for lunar landings use Starship to do the burn, sending astronauts to the moon from Earth orbit.
And one other cool ad, NASA is putting 2 SpaceX mini lasers
so
on Orion connected to our
7 minutes till
with the goal of enabling
propellant
4K
load
imagery
complete
and video from the spacecraft.
So
while
T-minus 250
that's going to be pretty awesome to see.
Awesome
should be
views,
booster
sure.
prop load to T-minus
for next year as we all work together to send
T-minus 2 minutes 10 seconds ship.
Speaking of sending
propellant
humans to
load
space,
should be complete.
former SpaceXer and current NASA astronaut Anil Menon is actually up on the space station right now as part of Expedition 74, and he captured these sweet photos of Starbase during an ISS flyover.
Oh, there you
Hi,
go,
Anil.
BJ.
We're all waving back at you, buddy. It's awesome to see the whole picture here as there's lots of facility and infrastructure development going on, but Starbase isn't alone on that front.
Yeah, it changes every day.
Yeah.
But talking about other locations, work is well underway in Florida to get pads 39A and Slick 37A ready for future Starship launches potentially later this year. Starship launches from Cape Canaveral are key to hit the necessary launch cadence to get back to the moon, build a moon base, head to Mars, all the exciting stuff ahead in the future.
Oh, what are they building
exactly.
at
And
Sanchez?
that future gets closer and closer with tests like today's
Gigabit
flight.
platforms.
And with that, we are just under 6 minutes
Oh,
until
nice.
launch. So that brings us to terminal count. Excitement is definitely gaining traction down here as the crowd is gathering just behind us on the lawn outside, and happy to say, still not a cloud in the sky. Dan, how are things up at Mission Control?
Things are still looking really good, Kate. We are still not tracking any holds on the board, no issues with the vehicle or with the pad. Our range continues to be green, both in the Gulf and out in the Indian Ocean for flight today. We'll continue monitoring that all the way down into the final minutes. We are going to be closing out our propellant loading on the booster and the ship within the next 3 minutes. We're going to have about 11.5 million pounds of liquid oxygen and liquid methane on both of those stages once we're all done. Then it'll be time for the pad to essentially ready itself, where we clear out all of the prop that's been flowing through feed lines up into the launch mount, up into the tower. Those go back into the propellant farm, get it ready, and we'll do those final thrust vector control, those steering checks as we get a little bit closer. If we need to hold that hold time, it's new for this launch, and we saw it briefly on our attempt last week. That hold is set at T-minus 60 seconds now. That's where we can pause, we can wait. If we need to just kind of hang out for any pressurizations, anything like that to clear, we've got a couple of minutes to hang there. We will only hold if there's an issue, and we're not tracking any holds on the board right now.
That's right. Now, once T-minus 60 seconds passes, a number of events will
And thank you
occur
for
in
Fly
rapid
Jake for
succession.
$10. Let's
Both
go
the ship
RGB.
and booster will configure their comm systems for flight, and they will rapidly run leak checks on gas and fluid tanks. Meanwhile, the booster will be going to internal power, and its engines will get their final priming for launch. Those ship engines will also begin their ascent bleed profile, and it will arm its automatic flight safety system. There's a lot of mechanical activations on the tower side as well, with one critical step being unlatching of the quick disconnect, feeding propellant into the ship.
And once T-minus 60 seconds has passed, we still have the ability to rapidly recycle the count under certain conditions back to that T-minus 60 seconds point and hold there to assess what happened and if teams can proceed once again to T0. There's an estimated 5 to 8 minutes of hold time, and that's largely driven by the propellant temperatures that we see on the vehicle while holding. The flame diverter on pad 2, you can see it there at the base of Starship. That activates at T-minus 17 seconds. Now, if we trigger a hold after T-minus 17 seconds, that will result in a scrub for the day, as we've already turned on the water. Now, for those that have just recently tuned in, once again, our primary test objectives for today's test flight includes a successful liftoff, stage separation. We also plan to deploy 20 Starlink V3 satellites. We have real satellites on board. We expect to have about 20 minutes of available time to speed run some tests and really allow the Starlink engineers to put them to the test in that time.
That's right, and we also have the soft splashdowns planned for both the booster and the ship. Going to be super exciting to see if we can return those safely back, so that way we can get ready for tower catches again.
And just a quick check-in, we got our final green light from the range, not tracking any issues on ascent or out in the Indian Ocean for entry, so it was kind of the final go.
T-minus 2 minutes. Go SpaceX.
Prop load now closing out on both vehicles. We have no holds on the board. Again, that
prop closing out on both vehicles. Let's go.
We're only going to hold if there's a reason, and currently there are no reasons.
Now, coming up here in a few seconds, we should have, actually right there we can see on screen, that's the base of the Super Heavy booster. Those are the 33 Raptor engines, and we expect to see and there they go, the TVC checkouts, also known as engine wiggles. We're activating those thrust vector control actuators to ensure that those center engines and the inner radius as well.
Yeah, that is so fast for as big as those things are.
Steer the rocket.
Yep, super cool to see how fast those move. I mean, in flight, it's amazing to see how it steers the vehicle. And we're coming up on that T-minus 1 minute now on our countdown, so let's listen in to see if we pass that gate.
All right, we are through the gate.
T-minus 1 minute.
Board. 50 seconds to go. Starship getting ready to fly.
Okay, Mauricio, be getting in a position to get that on the camera.
Interesting. They moved that discharge out there in the
flight tractors go for launch.
Out in the expansion there. It's not even over by the horseshoe anymore.
30 seconds.
-9, 8, 7.
Less than that 6, if you jump live a little 5, bit more. I think 4, our stream, that's our 3, stream that's delayed.
2, 1.
Ignition. And liftoff. Yeah, you need. Looking at your, I was looking at yours in Discord there, and not live with the actual live feeds.
I've got it.
Yeah.
Vehicle is pitching downrange. Booster Raptor chamber pressure's nominal.
Go SpaceX.
Got all 33.
Yep.
30 seconds into
there's a 270 roll. Oh, we've got placards. Cool.
Super heavy booster arcing away from us here at Starbase.
Decals, sorry.
Yep, one benefit to last week's abort is that they could put them on in the meantime.
Pressure,
yeah,
which again,
that was funny.
Flight is going to be higher than it has been on any of our previous Starship flights.
This view is really cool, just because you can see all those drill points on the tiles that they were doing before, and right before they do stacking.
Right, so we're passing through that.
Max security. Wow, that happened fast.
Pressure over a minute now into flight. Still seeing 33 out of 33 Raptor engines lit and burning.
What a beautiful day.
Our next major moment's going to be coming up.
What was that? Max Q around 25,000 feet.
Sheesh. When we're going to get to hot staging. We're going to shut down all but 5 of those engines on the booster. It's our version of MECO. Most
booster's looking healthy. Nice, everything's looking good.
Ignite the 6 engines on the ship while it is still attached, to do that separation. As a reminder,
okay, the plume's gone invisible, so we pretty well got no air outside at the moment. So what are we, 30 kilometers? What's that? 60-odd thousand feet, 70-odd thousand feet.
It's like doing a flip up. It'll go towards the bottom of your frame. We do that by lighting the engines in a slightly staggered.
Oh, sorry, 100-odd thousand feet. Sorry.
Standing by for hot staging.
So is it 50 kilometers? No, it's 80. It's 50 miles, isn't it? The Kármán line those days. 50 kilometers up.
All but 5 engines down.
Oh, what's happened to the feed?
6 ignite.
Burn startup.
Oh, full boost back.
Yeah, all 33 showing on
booster now
telemetry.
Doing its boost back burn. It looks like we lit all 33 initially. Now we're down to 13. We're seeing 6 out of 6 Raptors lit on the ship.
Oh, perfect. Down to 3.
Back burn shut down.
And boost back burn.
Go booster.
Down. So it looks like we were able to get through the boost back burn this time around.
So they didn't quite show the hot staging as normal then.
And we've got 6 engines lit on the ship. All right, so
what an amazing start. Oh my gosh.
2 burns that the booster is going to be doing to kind of send it.
Yeah, I know we didn't get to see the offboard, the onboard of the hot staging, but that engine bay on booster was pretty cool though.
All the way down to do a landing burn.
Yeah.
We're going to use those 13 center engines. They're going to ignite. That's what's going to really bleed off all that velocity that is built up. And it'll eventually, hopefully, transition to 5 engines to kind of fine-tune its path in, and then all the way down to 3 for the remaining bit. All right, we've got a couple of minutes to go until we get there. So
looks
booster's
like
going to coast for a little
just
bit.
pitched up for a little bit.
Still seeing 6 out of 6 Raptor engines lit. 4 minutes into the flight, ship's got about 4 minutes left.
It did. It pitched up a little bit more there for a little bit.
Nate, how was the view from from down there?
It was incredible. I mean, it just shot off the pad, and seeing all the crowd now running back inside to take views on the screen here, it was amazing.
Yeah, one of these days I'm gonna learn to not stare at the engines.
Little aliens there at the bottom of the booster, I see.
Blob in my vision. But now, speaking of vision, we could see.
We got ourselves about 2 minutes until landing burn startup.
Starship's second stage is still firing its engines. You can follow along with that with the GUI down on the bottom right-hand side of your
At 2,000 kilometers an hour. So that's, well, at sea level.
Following the planned flight path
Speed of sound is 1,000 kilometers.
The planet Earth there behind the ship.
That's right, and we're actually getting a live shot off the booster right now, an onboard camera.
2,500 clicks
from Starbase, where it just lifted off 5 minutes ago.
On nominal trajectory.
We are there.
Trajectory's looking good.
I kind of want to run back outside and wave.
Right. Now, again, this booster is not planning to come back to the tower or to launch site for this particular launch. We are going to be planning to do an ocean splashdown just off the coast of Starbase. So hoping to still get some amazing views of that.
Engines are looking perfect. Where's that red glow again? Let's go with that.
Pretty awesome to see the Raptor engines there on the left-hand side of your screen. We can actually see the plume there of those.
So that appears to be normal. There's a bit of a red glow between
the sea level
the
ones,
two
well
sea levels too up there on the
three on the larger ones on the.
Yeah, if you go back to that engine, if you look at the booster right before hot staging, that engine bay that they had, like you could see all of those. You could see all those. A bunch of prop lines were all glowing up there.
Landing burn to slow the booster down. Hopefully, we can get a live camera of the booster right now as we're going into that phase. Awesome shot. You can see it there.
Slowing down.
So right now the booster is using their 3 hypersonic grid fins to guide itself through the atmosphere toward its landing site. You can see we're only 5 kilometers
landing
above
burn
the
coming up
right here.
Just heard the call out for landing burn startup for
there we go.
The booster.
Oh, that's not good. Got 8.
I have a feeling the crowd's about to go wild here.
Well, we're gonna hit hard.
Yeah, I think it's going to hit hard. I don't think enough lit.
And another awesome landing for Super Heavy.
Nope.
Congratulations.
Didn't get all 13
all
on the initial startup.
At our SpaceX team, an amazing view.
Everything continues to go well with ship, as you can see there on your screen.
Yeah, it looked like 10. Looked like 10 started, and then 2 and 10 started up, and 2 almost immediately shut down, and then some more went down.
With the ship engines on, just looking at the booster real quick, it didn't look like we lit all 13 engines that we were planning for that
that was
landing burn.
Quite awesome up until that point. I still think it went pretty good, but yeah, not landing right. It's not good.
Still, so
it looks like we're not having a catch on the next flight.
High, but
not with that performance.
Really cool to make it all the way back this time to that landing burn. We'll dig
What's going on? Engine startup.
Out how to turn on all those engines. And then get to
in atmosphere. So up in space, engine startup restart was fine, but not so good down in atmosphere.
Yeah, it was the landing burn, the startup that didn't work out so well. It looked like it was a boost back. It looked to be perfect.
Sounds like we just got the
absolutely.
Boom
yeah, we sure did.
That was awesome from the booster splashdown. And engine shutdown.
Perfect.
And shutdown on ship.
I'm not sure if we got pictures. Let me have a look quickly.
All right, Starship 6 Raptor engines have successfully shut down.
Yeah, I don't see any.
Nominal orbit insertion.
And there's our call out for nominal orbit insertion. So we got a ship in space. We've got a booster.
I got some good takeoff shots.
Gulf where we were planning to send it. It's a hell of a start
nice,
today,
well
Kate.
done. Oh, they're really good
sure
photos. Let's show one of these.
All of our colleagues here are filing in through the doors. A lot of people wanted to stay outside and hear the boom, and so it's pretty great to see a ship in space, and everybody's super excited down here.
That's right. And as guaranteed, it has been an awesome day so far. All this action in just 9 minutes now. And objectives are done for the booster. Just want to quickly flag that booster did land in a clear zone. We clear those before launch, well ahead, so that we ensure everyone is safe before the launch and after. So we're getting ready now for our in-space objectives.
Like a tile liberated
we've got a few
itself.
minutes until the next milestone. So
actually, I see
sit tight
2 tiles
and enjoy
liberated.
the space views and of
floating
course
away in the
jams.
feed.
We'll be back here at T+14 minutes to deploy our payload, which is 20 of our newest Starlink version 3 satellites.
There you go.
So
Just want
we'll
to
see
take
you
up
soon.
photos. There's quite a few. I'll just jump back to one on the pad here. Takeoff. We'll do a takeoff sequence. There's the initial water deluge startup. Everything's closed out over there. Might jump forward a few, hang on. Over to here. Engine starts here somewhere. Okay, we can probably kill the SpaceX audio in a stream now. 16s. Okay. Yeah, awesome. Thanks. So that's actually engine ignition. See the steam starting to happen. Talk about rapid fire photos.
We did get deluge.
On the landing?
Correct.
Oh, nice. Oh, the photographs. Okay, yeah. So we've got lift off there. We can actually see some plume there, I think. Yeah. What a deluge on landing.
Yeah, it looked like the chopsticks did a little wiggle and the landing rails came down in sequence with it, but they didn't do a full close.
The plume in the sky. Cool. Can't see the water deluge on landing. Did we get a photo? Just say a bit, dudes.
I was just looking back at some of the Lab Padre footage
Right.
from their streams. I don't
know if we got. Yeah, I was just saying. I was looking at that. I was also looking at the sticks that moved a little. Well, the rails came down.
Yeah, it looked like they closed. There was like a slight close, and then yeah, the landing rails came down.
Yeah.
I'll be back in just a second.
Yeah, I don't think they moved. I think it's just landing rails came down. Don't think the sticks actually moved. You got the deluge though. Doesn't quite matter as they didn't exactly do the whole landing burn properly.
Sounds like SpaceX is back.
picture perfect from here at Starbase.
Picture perfect, and then we continued with that booster hot stage separation. Amazing to see some live replays of that. And of course, the booster performing its own boost back and landing.
Yeah, ship continued for about 8 minutes with all 6 of its engines and made it to second engine cutoff, where we heard good orbital insertion, and we've been coasting in space for the last few minutes. Now we're getting ready to deploy our very first real Starlink version 3 satellites. The door will be opening here in just about 6 seconds from now. Now we won't have the same views as we did on Flight 12 of our payload. We don't have those cameras on board these Starship version 3s. That was a Dodger Dog.
Okay, where are we up to?
We will be able to see them deploy from the ship.
About a minute and a half from payload deploy.
As Kate said, we should see the door open up really soon if we haven't quite gotten it open already. We've got 20 of these Starlink V3 satellites. Looks like the PEZ door is open. And so, yeah, this is the first time we've got
okay, I'm back on headphones.
Getting ready to go into space. And I mean, these things are really just kind of crazy upgrades that they're going to.
They're looking good. Our payload deploy, cool. Nice. 26,000 kilometers an hour. We're climbing. Are we still?
Pretty much anywhere on the planet that this is going to unlock.
Speed's going down
really
slowly. Altitude's going up slowly.
These satellites are only going to be in space for about 20 minutes.
So what are we, 40 minutes, so roughly 40 minutes, I'll less than that now, 30 odd minutes. From now would normally be a orbital, would be the circularization band.
This is essentially just giving us a chance to try and run as many tests as possible, deploy the solar arrays, antennas, whatever we can on these vehicles. We are intentionally being a little scrappy with it. They might be playing some bumper cars once they're out of the door.
Where's our inside shots?
Looking to get
What's going on? Oh, I see.
Over the next couple of minutes. In the meantime, they're getting ready to also do the Raptor in space relight. Listening to a little bit of conversation on that, but we are currently tracking to do it. I'll give you some updates if we hear otherwise.
Yep, first one moving.
And there you go.
Maybe move the picture out of the way.
Our first Starlink V3 getting deployed out of Starship. Huge milestone for the team out here.
Yeah, the crowd is definitely hyped about this. We could see these Starlink
funky music
continuing to pop out with deployment assisted by the PEZ dispenser.
Oh, thanks. Yeah.
Now, this version of Starship is built to deploy up to 60 of these more advanced Starlink version 3 satellites. Each V3 is designed to offer 1 terabit per second of downlink capacity. Now, let's put that into Falcon 9 terms real quick. A Starship launch...
Sure would be cool if we could get onboard footage of them actually taking and sending one of the, extending one of the solar arrays on those. Even though it's in the dark, so it's probably not possible.
And anybody that follows Starship...
Yeah, like send one on the camera ones out first with its spotlights, and then followed by a Starlink.
It's given us just this unprecedented
look. You might get a picture of it then.
Starship as it's flying through space, hurtling through
the
atmosphere.
No onboard stuff at all. I wonder it's because it's actual...
The dozens of cameras
no, the last lot was Starlinks as well, weren't they?
Real-time data.
Yeah, so far they're just giving us the flap view. It's like 4 have them been deployed now.
We use the exact same constellation to power all of our cameras that we have out in the field here in the Indian Ocean. So really powerful technology for just connecting you no matter where the heck you are on the planet, off the planet. So thank you, Starlink, for letting me watch this stuff as we fly through space. It's pretty awesome. We get about 240 megabits per second of data rate off Starship, which everybody in the spaceflight community knows that's pretty insane when you're usually dealing with single digits on some of the older systems. So gives you a lot of insight, gives you a lot of ability to just rapidly iterate, know what the heck happened when things go wrong. But Looks like we're seeing some more satellites get out the door. We do have cameras on some of them. The last couple that are going to go out are going to try and do the heat shield imaging that we attempted last flight.
So we could have that when they're talking 16s. We could have SpaceX
on Flight 12
audio on the YouTube
see
stream.
the satellite leaving Starship. Those aren't on the V3 satellites, but we are going to, on the last couple that go out, have some pretty narrow field view cameras that are going to be looking back at Starship, turn on some flashlights. And this is a test of a capability that we're really going to want.
Hey, welcome back, Indy.
When we start doing orbital flights, to just add that extra layer of safety, that extra layer of reliability,
Indy's
where we're going to be able to image Starship's heat shield after it's gone through ascent, after it's been in space, before it re-enters. So we're going to try to test that again today.
There's some port photos coming through.
Shield imaging. We didn't
what
get
do we got so far? I have some launch site photos
on planet Earth below us, but a couple more satellites.
So tomorrow afternoon, Texas time, we're going to do a show and tell.
Awesome to see our V3s in space. I want to give a shout out to our Starlink colleagues. And we expect payload deploy to run until about 27.5 minutes, so about another 7 minutes here. The Starlink team will be attempting to speed run these tests, or excuse me, speed run test these version 3 satellites, where they will attempt to do a few tests, such as extend the new solar arrays and antennas. They're also going to try and connect these V3 satellites with ground stations and turn on the satellite's communication systems. Now, they're only going to have about 20 minutes or so to do all of this, as these satellites only have that long before they demise in the atmosphere or break up due to that friction when they re-enter the atmosphere. So what we learn from today's deployment will help progress.
There's a satellite image straight away. Is that the takeoff plume event dudes already?
You can basically say that
is that
NORAD's payload is data.
It's GOES.
That's right. We're getting very Inception here. Now, in addition to those tests for Starlink, for the Starlink team,
that's pretty cool.
As Dan mentioned,
it's how we track where the things
satellites
actually land at.
Modified
kind of guesstimate where it's supposed to be.
To help scan Starship's heat shield.
Okay.
That will help inform our
well, that and the boats that sit out the buoys.
For future catch returns back here at our launch site.
We are. So you're secretly a SpaceX employee.
We are currently capable of
people in the community that track things. I'm just incorporating into the we.
We have not yet attempted to catch our second stage or ship.
SpaceXers have GPS, GNSS, all kinds of telemetry. They don't need pictures to triangulate it.
We are still planning to do our water splashdown in the Indian Ocean, so stay tuned for that. That's only about 40 minutes away. But still in space, we keep on deploying our Starlink satellites. Again, these are our V3 version of our Starlink satellites, a whole host of added capabilities.
Have they said why they're not showing internal photos?
I'm curious if it's some sort of secrecy thing, but don't know.
And this is our team here at Starbase, Texas.
These are all of the team members that have helped build the vehicle, that have built the Pez dispenser, and got it ready to fly today. Amazing work.
Now, for those of you that have just recently tuned in, there is a spaceship in your screen, we promise. Right now, the ship is in orbital darkness, so we don't have any available sunlight from the sun to help illuminate the scene. But what you can see moving out from that smally lit space, those are the V3 satellites as they are being deployed. And essentially, the ship is illuminated from the inside, and so we're able to see the light come out through the payload door.
Right. Just a really small sliver of light at the top. That's our Pez dispenser. That's how we're both loading our satellites into the rocket and deploying it. It's pretty novel. We've got about 3.5 minutes still left of our payload deploy sequence.
Yep, looks like we've got 16 satellites deployed, so 4 more to go. These last couple will have those cameras, so if you see any sudden bright lights, that'll be flashlights turning on those satellites to try and get some imagery of Starship's heat shield. 17 out the door.
Oh, we'll see the ship light up when I turn the spotlights on.
Yep, and Mauricio landing.
Ah, cool.
All right, and while we wait for these last two, we did confirm we are still go for our Raptor relight demonstration a little bit later in the flight today, so we will be looking to relight one of those Raptor engines on ship. And that'll be our next major milestone after we get through these final two satellites.
Just at 25 minutes into our flight, it's crazy to think that we're already screaming at 27,000 kilometers an hour, 200 kilometers above the ocean surface. Amazing.
Yeah. Now, for those of you that lost count, we have deployed almost all of our 20 Starlink satellites. I believe our last count was at 18, so we should be seeing 2 more. And we're very excited
to see. Oh, they're starting to bridge over the doors, BJ, over the main doors, the Gigabay.
Like, these are real.
Yeah, we saw that the other day. We saw the lower beams were being installed during the Mauricio's drive by the other day.
Where our Starlink engineering team will
if you go back there, some of those short roof trusses that they built a while ago have also been installed on both sides of the center wall, nearest Mega Bay.
In that 20-minute time frame, we can really try and pick out as many tests.
Yeah, down at the bottom. Down at the bottom of the image.
Yeah, lights
on. On the balancing them like they did.
Starlink satellites, as we mentioned before, a few of them, 6 of them actually are equipped with flashlights to look back at Starship, as we want to see the heat shield. And
we don't have pictures on YouTube.
Performance through the ascent phase.
No, not yet. Sorry, YouTube.
To know and understand
16 might start showing that
for operations that will enable ship to come back
light
to
confirmed.
Starbase for landing. For catch, I should say.
Right.
Oh, no, but I only got.
There we go.
Okay.
We are about 40 seconds away from that slam.
So while the ship's coasting away, did we see the ship light up?
Yep, looks like we've just got
from one of the spotlights yet. No.
Okay,
so YouTube.
Did you hear that?
These ones might be coming out. Oops,
no.
Starting to see
yes, it lit up. Light confirmed. We're all good.
Oh, there we go. I see. Yep, right now. Yep. Nice.
19 out the door, one more.
More lights.
It looks like we got a crowd at our Hawthorne, California location. Some colleagues gathering outside of Mission Control.
You might get to see your that one didn't have lights. You might get to see the
20th. So our
solar panel deploy yet.
Is now complete. Starship will now.
Yeah, you can see the shadow of the 20th one in the from the lights of the 19th.
Still a lot of major events to come today, including our Raptor relight burn at T+30.
Okay, back to Gigabay.
Should see a roll here so that the heat shield goes towards it.
All kinds of light.
Eventually, our splashdown.
Payload door closing. Nice.
And go on to another quick coast.
Yeah, so sit tight, enjoy the views, and
okay,
of course,
so far so good. Everything's on track.
We will come back here at
so no engine failures, so we should see the engine burn should happen too.
And of course, Starship re-entry.
I'll be right with you, YouTube.
Yeah, you can see the train to the left of them look like.
Oh, yeah.
Purple is usually IR. I'm not sure if that's what that is. Actually, I don't know what that is. Never mind. That might just be one. I was thinking maybe they fired the Argon thrusters or something. I don't know.
I'm not saying it's aliens, but...
Well, this is definitely not helping that case, because that's going to... Yeah, because you can't see the solid frame of it, so...
Yeah, we're still showing Gigabay. That's fine. So we'll go over to Gigabay. Apologise, but we're still sort of getting our act together with these launch videos. It's all good. It's no worries. We're doing a good job, 16s. Yeah, so back to Gigabay. Most of the level 7's pretty well in place.
Yeah, the last of the non-doorway columns was installed a couple of days ago, so.
Nice. So we've still got a bit more steel to put on the penthouse level, don't we? Down in here somewhere.
Well, the penthouse level steel won't go in until the roof trusses are done, because the bottom core of the roof truss is the penthouse floor.
Of course. Okay. Yep. That makes sense. Yep. Thank you. Before we're talking about there, these two inner ends of the trusses have been put in place. So these ends we saw obviously over the last couple of flyovers, and then the big bridge trusses sitting down are yet to be lifted up. So the actual truss sections are lifted up by the crane too. I guess that's the end of that's the last job for the cranes, is it, putting the center sections of the trusses in?
And then putting all the roof, and then putting all the rest of the filler roof beams in and all that. But once they're outside of roof related stuff and penthouse floor, then they'll be done.
Okay, so still a bit to go. Cool.
And for those watching along with the SpaceX stream, it looks like Ship 40 has made its full 180-degree roll for the cameras to look at the heat shield.
I think that's just the flap moving, but it's hard to say spatially if it actually rolled or not. I think
the telemetry. The telemetry in the bottom right.
True. Yeah, that's true. Yeah. I was so confused with why the flap was moving. I was like, you ain't flapping on nothing up there, so we're just taking pictures, obviously.
Yeah, when it's just looking out, and when the camera is just kind of looking at itself in darkness, so you can't really tell what's in the background.
Yeah, they flip left to right, so it's kind of confusing. So,
is that still a vent or a leak? Something going on down there at the engine bay?
Yeah, it's probably engine cooling because they're going to come up on the relight here. 7 minutes.
Okay.
But they deplete the tanks as well, I believe, is what they were doing.
Of course, yeah. Okay, what's happening with the OLM? Oh, we've got new parts for the middle section. Cool. Oh, and they're setting out the flame bucket parts.
Yeah.
Cool.
Yeah, I had noticed they had started working on that earlier in the week.
It's back. That frame's back from Sanchez. That's weird. Moving stuff around over there where they're making platforms for some reason. There's still no corners for the bottom level? No.
Oh, neat shot coming up again. We got the sun. Or, no, it's a satellite light. Okay, that's cool. Neat.
Oh, it's not very far away. They might have used some thrusters to stop it, to stop it moving away from the ship.
Yeah, it's right there. It's got 4 big old lights on it. Unless those are 4 individual ones, I guess that's possible, considering the spatial viewpoint we're trying to get at here.
So they're moving the flaps in front of the cameras also for the engineers to see the flaps moving.
Yeah, because flaps ain't doing anything right now, obviously, so...
Correct. Oh, so, okay, that it's going to build the flame buckets right on the roadway. I thought maybe they'd use that corner, but not. They're just going to use the actual roadway. Cool. Oh, well, they've made a detour for themselves there as well. Very good.
By the way, that angled piece that is not the piece that went to Massey's and came back. I think that might be something else, but I don't have any close enough views, and obviously our previews don't let us zoom in very far.
Oh, that thing, the black.
Yeah, I'm hesitant to say it, but it almost looks more like something towards the tip of a SQD arm or something.
Yeah, because it's only got the tube steel. Was it the same? Yeah, it was different. Sorry, yeah,
and
right.
and it's only angled on one side. It's not. It's like one side's squared off and one side's angled, like the tip of the shoulder section.
Okay. Oh, look at the nice high res photos tomorrow. But yeah, get a bit of an idea what's going on today.
Was that the SQD? Was that that little piece we saw, that stand we saw?
I think that's SQD hardware. I don't think that's the stand. And that stand rolled back, one of the other flyovers earlier in the week didn't show it. Well, actually, it showed it just arriving, so we don't know where it ended up at.
Oh, okay.
Casper's in chat's agreeing with the SQD assembly started. So is that further over? Are they going to do that there or further over here? I suppose cladding has to finish first for there. Over here it was, wasn't it? SQD last time. Oh, hang on. No, it wasn't. Hang on. No, it was here.
Yeah, the SQD was closest to the inventory tent, yeah.
That's right. There's pipes and other GSC going on over there. Booster 18's still with us. There's hope for it yet. Oh, look at all the satellites in the background on the Starlink live stream. That looks really cool.
Yeah, I got a train going down there. Yep.
Is that a star to the left? Is that Mars? Are we seeing stars?
Should be the planet.
Oh, the planet. Okay.
I think if we're pointed down towards it, should be. Could also be a satellite. So.
Yeah. So engine burn. Yeah, we're gonna get the heck away from them satellites when we do that engine burn.
And big shout out to Philokid, $50.
Oh, thanks, PK. Appreciate it. Good on you. Are these tanks new? Down? Are these the ones from the port?
Those are the verticals that were over in the corner by the between the Tesla packs and the generators.
Sorry. Yep, I knew that. I knew that. Oh, I got some really good photos. So have they finished that side of the cladding? Let me see.
To go into orbit.
Oh, they're doing a single rail around the Gigabay now, BJ, of cladding.
Yeah, I think with where the nets are and stuff like that, I think they were kind of limited on that. I'll be curious to see the high res or some of the ground images. I haven't looked recently to see how the bracket installation has progressed.
Yeah. So would they be doing the bracket installation from the outside or from the inside?
I think they can reach it from the inside because that's the crews that are kind of working on the top side of each panel seem to be doing the attachments from inside.
So we've got good photos of Massey's again.
Expecting a 14-second burn. That's pretty impressive.
Well, that'll change its,
nice.
Trajectory a lot.
Amazingly nice.
Yeah, that is good views.
What are we looking at there?
It is insane.
Wow. That venting? What is that? That is absolutely beautiful, though.
Yes, it'd be nice if they just didn't do that, but they have to do it, so.
That looked crazy.
Yeah, the ship is enveloped with all of its kind of semi-fluid gases and vapors that causes all kinds of, cool effects.
Okay, next event will be re-entry.
Yeah, so you're getting like all of these light effects because there's no real light source. The light source came from the engine, which then it disperses into all of this cloud, and you get these cool ripple-looking effects going on because of how the light reflects off of it.
Glad you're watching the chat there. 6 stones, that was a weird comment we just deleted. Now, let me see. That frame at Massey's.
It's not
it's been moved.
Yeah, it came back to Sanchez. We just don't know where because during the midweek flyover, it was like about to turn into Sanchez when they were flying.
Okay.
So we know it came back. We just don't know where. But that item that we were just looking at is not it.
Because there was a photo from the ground of a frame going back up from one of the lab cameras, and it definitely wasn't the same frame. It had tubular steel rather than the square steel. So there's 2 items that kind of look kind of similar. So 18.3 has been removed from the can crusher. The
39.1 no longer has a cap.
Yeah, top hat. So it's probably going to pop out soon. So that's on a stand ready for SBMTs, 18.3, 38. And there doesn't seem to be a stand for 39A yet out here.
Just wait, it'll go back on the ship. It'll go back on the ship cryo stand. The old one.
Or in the super crusher.
Or that too.
Bit of modification required there. Oh, hang on. No, maybe not actually. Because 18 doesn't have clamps, does it? No, so it might drop straight in.
Yeah, both of those articles have a bare ring at the bottom of them.
Oh, we're back here on YouTube. Cool. Yeah, so 18.3 is out. 39.1's lost its top hat. The concrete's been poured. We didn't really get a... Did any of the midweek flyovers show any more detail of what was underneath that concrete slab?
No, it was just that kind of the L-shaped slab wasn't there yet. It was just the rectangle that was there. Seems to be, yeah. I think we missed some install in there, or it's just a slab.
Yep.
And a beep open text just came.
Nice.
I've done something to this concrete ring. There's some
They just added
bits.
Yeah, there's 5 little plates on there.
We get a close up of that. Oh, here we go.
Reentry starting to be plasma.
Yep. Five plates. Oh, that looks good. The little inset there, 16s. Good job. You're doing well keeping up with us there, 16s. Well done. Especially we have absolutely no schedule and no forward planning or anything to do with the stream today. We just sort of jumped online and just winging it basically. Whoa. Oh, there's another ring, possibly for 39.1. Okay, SpaceX are talking again. Probably put their audio back on YouTube.
Which is really the main reason why we do these flight tests, is to see how the ship performs in space and evaluate how it works. Starlink provides us with one more path to collect data to help us rapidly iterate Starship's design.
Yeah, exactly. And if the ship manages to again make it all the way through re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere, and it's doing so at hypersonic speed, or more than 5 times the speed of sound. Re-entry is typically a portion of flight where we don't have communications with spacecraft because it's re-entering at or around orbital velocity, which is roughly 8 kilometers per second.
Yep, I guess because they've got a watermark on them, I guess they're free to share
so at those speeds, the spacecraft is moving through the atmosphere so fast that it creates a plasma field around the vehicle.
That blanket of plasma distorts communication frequencies, so it's not uncommon to experience brief blackouts in communication. Starship is designed to land on Mars, where there are no runways or other humans to help out, which is exactly why we're testing this landing procedure that we're doing today. And we're doing these propulsive landings instead of more traditional means like parachutes.
Fair way to go, yeah.
Flaps have taken control of the vehicle.
You heard that call out, flaps do have control of the vehicle. You can actually see one view, your screen moving around. That's actually a camera affixed to the flap. So as I was saying, we're testing these, doing these landings instead of.
We're at 83 kilometers up. There's enough atmosphere for the flaps to become effective.
Yeah. Now we did just hear that call out.
Well, they're going pretty fast.
So hear some call outs as the ship makes its way back to Earth. Now, when we hear something called
they're getting like about 4 molecules per
as well as entry
square
max Q,
cubic meter.
That means that the ship has made it through the maximum heating and aerodynamic.
It is slowing down, so it's hitting the atmosphere.
Experiences as it returns.
80 kilometers, so that's 50 miles. So that's like the
specific points.
What used to be the official Kármán line. The NASA Kármán line?
That's right, so we'll continue to hear multiple call-outs as we go through this phase.
Oh, somebody caught the relay, that's cool, from the ground. I was wondering if somebody in like Madagascar or something was going to catch that.
We'll hear another one when it's subsonic.
South Africa.
So was that in the direction of flight, or was that retro burn? The burn?
For direction of flight.
Vehicle are concurrently below
cool, so it sped it up a little tiny bit.
Above the speed of sound,
yep.
So somewhere in the
just
range
a tiny
of
bit,
Mach
yep.
0.8 to 1.2. For reference, commercial
15 seconds. Oh, okay, so they're not even high enough. Because circularization burns
just for
usually about that long, aren't they?
480 miles per hour to 575.
Well, it was just one engine too. So.
770.
And I don't know what thrust. I have no idea what thrust. I mean, you could probably deduce that if you had the telemetry and somebody wanted to figure that out.
That you'll hear later on in the stream.
Yeah, I'm not doing that math right now. No.
That are much less than the speed of sound. So,
but you're correct.
In flight, the ship's
it is a very
slowing down
figure-outable calculation. That's a word, figure-outable.
Entry well underway. We'll take another break and return just before the ship's landing burn, targeted for T+1 hour.
Looks like they've stopped working here on this site, the pump station. Oh, sorry, we're back on the pictures again. So how long now? Oh, it's not far now, I suppose.
The pump station. You mean at Brownsville?
Yeah, the pump station at the Brown lot.
By the way, we saw the picture of what I presume is the pump house. It had the chlorine sign on it, so definitely a additive site, as there would be. So apparently the door closed when he's trying to take a picture, though. So.
Oh, like I see.
The door is damaged too. It. Yeah. Well, it makes sense. You would normalize for potable water. You would normalize it. You'd have to do that. So.
But we thought they were already getting town water supply, which we thought might have already been chlorinated. That's all, but obviously not.
True. I agree, but I think you would just build that in there just because you're going to build it anyways. You wouldn't want to do it after the fact. Got some really nice blues. I always love these blues on the atmosphere. I don't know if it's the camera or if that's actually how it looks. So.
Yeah. How we going? 69 kilometers up, 25,000 kilometers an hour. Just a mere 25,000 kilometers an hour.
Super cool. As it's kind of like a vent going off, and it's mixing with the plasma, if you will, and it's creating that real cool blue jet.
That's crazy. There's stuff coming off the earth on the leeward side there. It's amazing. It's like different every single time they do it, to be honest.
We saw the other side cam with the same jet from the vent before, but yeah, this is a really nice view too. It'd be nice if they could get a survivable like Starlink V3 to see the kind of the exterior, but that would be very hard to line up.
Might be long.
Or like a selfie cam, like an extendo rod thing, you know.
Oh, actually during re-entry?
Yeah. Well, who cares if it burns off? You know, get some selfies.
I'm just really happy to start seeing some of these flap views and whatnot, and not being like, oh, is the flap going to survive? I mean, it seems that we haven't had any issues with the burn through that we saw for a few of those.
That was
early.
Even the early ones, they still survive. So I was like, I wasn't worried after that. It was no big deal.
Yeah, the flaps are solid as they don't burn through nothing at all. They're not even glowing. There's not even any glowing on the backside of the flaps.
I will say, very odd choice in what they've given us for views this go around. I'm not sure if that's saving it for video or what we're doing here, but very, very interesting choices here.
Yeah, I feel like on Flight 12 we got so many more detailed views than we're getting now when they've already done it once before.
Yeah, it's weird. The IPO went through and they're like, it was back to nothing. Should be coming up on max heating.
Experiencing a few G's there, slowing down. A little G meter would be nice too over there on your telemetry. We've been seeing G meter readings. Is that on crew launches? Is that we see G rating?
Falcon 9, they've switched to the G readings.
Cool.
Hey, we got another clean shot. Well, maybe. I haven't seen the actual launch, but close enough. The vapors aren't all over the tank farm. So.
Okay, yep. Star Park with they're gonna put these vertical or horizontal still? I'm still thinking.
Everyone.
Hey.
Quick question. You think they're gonna lower that TFR down to 5,000 feet since this just happened?
I don't know.
Like by tomorrow, right? Usually they take it off.
I mean, they allowed like an hour after the fact commercial jets to go through for landings. So, I mean, I think the official one, it's probably tomorrow, is how they usually operate.
Maybe you can ring the tower. Maybe Fred should.
It's
sure Fred
gone.
should know a way to find it.
It's gone, Mauricio.
The 10,000-foot one?
It's not on the TFR website.
Oh, okay, so they took it off right after.
Yeah.
In that case, I mean, we can do. So I did capture some photos after the launch, like I usually do. But do you guys want me to go? Because I can. Fred's available. I can do it tomorrow, and we have the funds to do it for tomorrow. So do you guys want?
Sure. All right. Is that for a flyover? Clean photos of the launch site, pre-launch. Yep. So you're back on the ground now, aren't you, Mauricio? Obviously. Yeah, I'm pretty sure I heard
Random shots of the launch site only, and then I need to recover one of the cameras because I think it might have broke. One of the cameras we left out there might have been too close to the pad.
Do it tomorrow, Mauricio. If you can do it tomorrow, then you can get the after shots and you can get everything, the ASU and all that other good stuff for Sunday. So tomorrow works if that works for you and Fred.
Okay, I'll let Fred know then. My only concern, yeah, I'll see. Yeah, because it is getting kind of late and we need to edit photos still. So my concern was that camera to see if what the condition was on that one. But yeah, we're good for flyover for tomorrow.
Yeah, go check the camera, and that way you can go home and do your thing. And then tomorrow we'll do it again. You can do a morning one, your time, and then we can do a show and tell like we normally do in the evening.
Sounds good. We've got some good tank pump photos pre-launch here.
The road is open right now, right?
Yeah.
Okay. So I think like just for the sake of time, I might just get photos of the launch site. I'll skip the build site for now. That way it could save me a little bit of time, and then I'll just do the launch site, and then I'll head home.
Sounds good. Thank you.
Thank you. Have they started putting a second row of sheet piles in? It kind of looks like it's got an edge now, the other side.
No, they've just been doing some excavation. It's just the single line in that crane, in the crane that was installing them, and the hammer left.
Oh, actually left.
Yeah, they broke it down at the same time that the LR 1500 from the ASU. Both cranes were being shipped out at the same time.
Ship is coming in hot. 55 kilometers altitude, just under 16,000 kilometers an hour. So we've wiped up a cool 10,000 kilometers an hour already. So it's about 30 odd miles up, I think that is. 54 clicks. Looking at the Indian Ocean, I guess, by now.
Yeah, you can see bottom right. Or, well.
Oh, of course, yeah.
Yeah.
Not far off Australia.
Yeah, looking pretty good. Some heating, normalized stuff. A couple tiles on the back side of the flaps fell off, but nothing major.
And no heating at the hinge point of the flaps at all. By now, I think last time on the first few flights, we started seeing burn through by now. We're going to have a ton of photos this week to put in our weekly video. Wow. There's some more concrete work out the front of Star Park, like they're going to stand a ship or a booster up there. Well, it still could be I still could lay them down side by side, but I'm still thinking they're going to put them vertical. Although, let's say booster was reinforced to hold horizontal load, so booster just, they may put them horizontal actually.
That's what Dave was saying yesterday, that they fortified it so they could do that.
Yeah. Be nice if they're horizontal, a lot easier to get a look at and everything. So we've finished with atmospheric braking. All right. Just finished peak heating. No more plasma.
Just under 5 minutes to landing, burn, and flip.
Basically no clouds there, so we should be pretty good.
Max Q. Re-entry. The flaps are hardly moving. It's sitting. Gee, it's stable. The flaps are hardly moving. It's just sitting there in perfect flight. That's actually quite amazing that it's sitting so stable, actually. I would have thought it'd be a lot less stable than that, and we would see the flaps moving a little bit to correct it, but the flaps aren't moving at all. That's incredibly stable.
Oh no, that bit's to come yet.
I can see a little bit of movement there, but geez, not much. So when does it? We'll do another U-turn. Do you think, BJ?
I forget where in the flight that those maneuvers end up happening. I would think so. I would imagine I'd want to continue to do those simulations of the approach.
Yeah.
Oh, we've done the re-entries, right?
Yep, we're back into post plasma. Oh, there we go. Something's moving around. What are we doing?
Yeah, we should be going transonic here in the next 10 or 15 seconds, according to the timeline.
We're not hypersonic anymore. We're back to supersonic regime.
Yeah, we go subsonic at 1:03 and 1 second, or 1 hour 3 minutes and 1 second by the timeline.
Oh, yeah, first maneuver.
Yep, here it is.
Thing flies like a bird. Gee, it flies well.
It really looked like it was made out of starlight. Now, we did hear on just moments ago that we made it through max heating and max dynamic pressure, meaning that the vehicle temperature and speeds and pressure are all coming down, and we can see that in the bottom left-hand corner of your screen. As
you can see some of that ablative on the edge there, flapping around a little bit.
The ship landing burn. One of pretty much everybody's favorite part of Starship test flight days.
It's gonna have some neat colors after mini flights.
In just about a minute or so.
Yeah, just about a minute away. We're gonna try and light all 3 Raptor sea level engines for this burn.
Again, sir, real quick, I did confirm the flyover for tomorrow, 9:30 a.m.
As we get close down to the water,
with Fred, so we're good to go. If you want to get a
soft splashdown, we'll see.
I don't know if you can do that stream, or do you want Six Silverstone to take over on that one? It's up to you.
Yeah, don't worry, I'll take care of all that. Thank you for letting me know.
Which, from kind of our initial look,
thank you.
It did pretty well on the flight uphill, but we'll continue to dig through all the visual data as we get it.
Unbelievable. Thanks, Mauricio.
We didn't do any real stress tests or anything.
Wow, you can really see the turning actions there.
Our landing large flight controller call out. We were doing the swoosh maneuver.
Over the horizon, spinning around behind it. Yeah.
That we planned.
Yeah, and when you look at the telemetry, you can just see how it's spinning. It's not rolling. It's I forget which direction that would be called.
And
that'd be yaw.
Yeah. About 10 seconds away. Look for 3 Raptors, the 3 in the middle to
yeah,
light
let's go full screen on the SpaceX.
Get this thing in the water.
Screen.
Flip.
Seeing healthy chamber pressures on. Did our flip down to 2. Starship descending into the Indian Ocean.
Oh, look at that. That is beautiful.
1. Very nice.
Oh,
no explosion.
And it didn't explode. Look at that. It stayed in one piece.
Oh,
we got a fire, but it didn't explode. They're going to be able to tow that sucker if they want to. Make some people happy.
That is a first. That is the softest splashdown we have ever had.
That landing looked more stable too.
Yeah. The Flight 12, it felt like it kind of spinning a little as it was hovering in there. It just kind of was really smooth.
Okay. What now? Shoot it?
Bring out the 50 cals.
I will say this, they do have the bigger vessel out there. It's the CM Time or whatever the name is. So I probably pronounced that horribly.
Oh, that looks awesome fighting there. Wow, it's fighting well too.
I was say, is it bad of me to think that V3 ship might get caught before a V3 booster at this rate?
Yeah, no, this is bad that people are going to make that comment like it's something.
Yeah. Tyler, how is Hawthorne feeling about Lucky Flight 13?
Wow. Hey, Kate, we are so excited about another successful Starship test flight and those gorgeous Starlink views that we had. And we can also confirm that we managed to make contact with all 20 of those V3 sats. So it's a massive day for us. So congratulations to everyone at the team at Starbase, for Starlink, everyone here and around the company who've contributed to the Starship program as we make progress again towards a multi-planetary future. So thank you everyone for tuning in.
They're going to be happy with the drone footage they get right now since it didn't explode. They can really, if it stays floating for a while, I mean, they're going to be able to just really inspect that heat shield like right now.
Oh wow. Oh wow.
I mean, that's going to be the best views they're going to ever get to inspect it post-flight.
See how the atmospheric re-entry.
I don't think I've noticed a missing. I don't think I've seen a missing one yet.
The edge of the vehicle.
Deploy
I don't
more
think we've
drones.
seen quite that close before.
Never. And honestly, however short-lived that ship standing, bobbing in the water is, that is insane data for our team. It's unbelievable that we were able to keep that ship afloat. Now, we promised maximum excitement, and Starship V3 delivered. Congratulations to all of our teammates at SpaceX and to everyone who supported the Starship program.
Back over the footage.
And thank you to all of our future customers for your support.
Descended on 2.
As you can tell, the crowd really enjoyed that Nemo cam for a moment. We'd also like to thank the fine people.
On board.
Ooh, look at that. On the flap cam still working.
The Federal Aviation Administration and the Government of Mexico.
The amazing views do not end,
that's crazy
so be
good.
sure to follow SpaceX on X.
That guy's render a boost to 20.
Shots that
He'll be laughing.
He'll
be
really
happy about seeing this.
And
we have transformed to being a whale.
Look
I like it.
At the teams bringing this incredible rocket to life. Check out the latest episode of our documentary series, Starship. And of course, thanks to all of you for tuning in. And we're going to head back up to Dan for some additional thoughts.
Yeah, I'm losing my mind right now. We are still getting views from on board the ship with it in the water. Like,
wonder why it didn't blow up this time.
We have tried in the past to do these splashdowns as softly as possible. We experimented with rolls.
I was going to say why.
This is the first time we've put an intact Starship in the water. This is a dream scenario for the team that's trying to get this heat shield data. Normally, you're working with a slightly
theoretically,
Starship
even manned whatever, they could
and now
abort
we have one
to the
intact,
ocean
so
if
the
they can
recovery team
do
is
this
moving
without
in
blowing
with
up.
their drones, and that we are still getting views from Starship. It is
and it's floating really well. It's high out of the water. It's not drawing much water at all.
While it is floating in
well,
the
I mean, it has
water
massive internal air as long as it's not
space.
breached.
Like this is just completely surreal right now. This is just a mountain of data that we're going to get back. This is going to be so critical for refining the heat shield, everything else.
I mean, it's still good, right?
The really good news is all of these views that we're seeing, you're looking at a pretty intact looking heat shield.
Yeah, launch it again. Go for it.
As a reminder, we were flying at a significantly higher dynamic pressure, so putting way more stress on this vehicle on the way uphill. And it's sitting there in the water.
Couple holes in the.
I mean, look at it.
Yeah, the aero cover.
But, yeah.
I'm
a couple tiles here and there with partial damage.
I know a lot of our team is just fascinated in the control.
Yeah, look at them getting up in there on everything they can while they can.
Everyone's gathered around their computers.
I don't think it's going to go
anywhere. Close-ups that we're getting.
No, I think
they're
going to probably have to purposely either they're going to have to tow it back or they're going to have to rupture it manually so it sinks.
Absolutely incredible, and the fact that like the cameras on board the ship are still sending back video is just a little bit surreal. So, wow.
Yeah, that is true there. Even the fact 13, that, I mean, what, the two antennas that are going left and right, but
water, really
4 out of the 6 antennas are facing the water right now.
Whew.
Yeah. No, is it heavy, particularly heavy on that side? It's sort of very stable that way up, too.
More of this.
So it's somehow deliberately like tile side up.
Some of the onboards that we caught.
You'd think the tile side would be heavier and it'd want to roll over.
At SpaceX, whole bunch more cool imagery from launch from the flight that's going to be coming out soon.
I think it probably has more to do with the way, just the way that they land and kind of the attitude that it is as it comes in for the soft touchdown.
Of Starship version 3.
Still venting too.
With that, we'll say goodbye.
Dang.
No, don't go nowhere. We're not done.
Yeah, we could just
say
stay
we're enjoying
those.
Yeah, the drone footage would keep a lot of people entertained for a while.
Oh, there you go, YouTube members. Check, that was amazing. Hey,
did we even check in with the 6-7 guy? I don't think we did. We didn't even hit him up.
No.
Interesting.
Well, thanks YouTube for hanging around for this live stream of the launch. We might let YouTube go. Thanks, Silver Sixstones, and well done for your production today. You did really well with all that. Thank you very much. And we'll look forward to tomorrow for a actual Flyover live stream and a show and tell live stream tomorrow. So that'll be Saturday US time. And thanks, Event Dudes and BJ, for helping with the commentary. And Todd.
Pleasure.
Anytime.
Yeah, anytime, but I didn't do much. I just sat there. Beautiful. Oh my gosh, that was awesome.
So, ship catch next. Gee, I don't know. Whew, like you said. I don't know. As soon as it goes orbital, yeah. Maybe one more, I don't know. It'd be very interesting to see. Wouldn't be surprised either way, to be honest.
Yeah, I'd be curious to see what the velocity was at in those last moments of booster, because I was watching it and it was going down like 1/10 of a kilometer a second, and I don't know what the math is on that even roughly. That sucker was coming in pretty hot.
Be interesting if they caught ship for the first time and not booster.
That's what I had made the comment before. I was like, the evidence so far is maybe suggesting that we might get a ship catch before a booster catch on V3.
That actually would be so cool, though. Like, that would be like the old days when booster didn't even exist.
You know, like them 2 oil rigs that Elon Musk bought. Why ain't he got one out near India to catch the ships? What's going on? Demos and Nemos were?
We still on
You're talking
YouTube?
about Phobos. No, we're done.
No.
It's still going.
Yeah, it is.